So good morning, everyone. Awake? Yes? All right. Sounds good. Uh, so any questions from the previous lecture that we covered the basics about networking? Any questions? Anything that you didn't understand? What is the IP protocol? What is the transport layer? Why do we need that? Why do we need transport layer? Can anyone tell me? Why do we need IP layer? Can anyone tell me? See, I need to wake you guys up, right? Uh, okay, so the IP layer is the third layer. The topmost layer is usually an application layer, which is where you have all the applications running, right? So your web server, your mail server, database server, all of these applications are running as an application layer. Then the application layer will collect the data. For example, if you browse the internet, if you go to a website, now you need to send the request to a particular web server, let's say www.google.com, right? So what essentially you are doing is your browser is trying to connect to the Google server, and it is trying to fetch the page, the web page, which is actually hosted on the Google server. Okay, so your application layer, which is your browser, is going to first establish the connection. Why we need to establish the connection? The reason being that if you don't establish the connection, then the data that you may get from the from the server, or the data you are sending it to the server, may have some problems. So what are the problems we discussed? One could be loss of packet, another could be duplication of the packet, and the third could be out of sequence packets. Out of sequence, because when the data flows through the internet, it does not always it's not always going to go in the same sequence. So for example, when you are sending a request to the web server or Google server, let's say you need to send the 10 kilobyte of data, you need to chop that data into 1 kilobyte each, because we are only able to send 1 kilobyte of data at a time on the network, right? So now when you are going to chop that data and create different packets for 10K data, each of those packets will be going through a different route on the internet. Okay, it's not always that it's going to follow the same route. So when it goes through a different route, the packets at the destination can arrive out of order, missed packets, or duplication of packets, right? So these problems needs to be solved, and that problem is solved by transport layer. So transport layer is required for what we call reliable service, right? So you see the third point, transmission control protocol. So that TCP is the protocol that runs at the transport layer, which allows you to get a reliable connection, reliable data, right? So application need not worry about whether the packets are coming out of order or missed packet or anything like that. It is the job of the transport layer to do that. Okay, the job of the IP layer, internet layer, is only to ensure that the packets are forwarded to the next destination. So for example, let's say you open the browser here, right, on my machine, but the Google server which I'm connecting to may be located in Singapore. Okay, so there may be multiple network that I have to go through, right? So there may be multiple routers, multiple local area networks which I have to go through, right, in order to send the data to the Google server. So the intermediate networks which are there, right, each of them will be running the IP protocol. So the function of the IP protocol is that you take the data at the source, you send it to the next router will send it to the next router, and so on, right? So basically what we call is it is hopping through the router till it reaches the destination. So the job of IP layer is just to ensure that you are forwarding the packet to the right destination, and the job of the transport layer is to ensure that all the packets are collected in a proper way, without any misses, without any duplication, without out of order issue. So that is the two important aspects that you need to know, right, when you learn about internet. Okay, there are two more layers which are there, but for this particular course, we don't really need to understand that in detail. But in case if you are interested in knowing the names, the layer below the IP layer is called data link layer. Okay, and the layer below the data link layer is called physical layer. So physical layer, data link layer, IP layer, transport layer, application layer. These are the 5 layers in the network which most of the current network uses. All right. Okay. So now, we briefly talked about how the data is sent from, let's say, client to a server or server to the client, and whenever the client, as I said, HTTP is the protocol that we use when we want to send the data to the web server. So we use the TCP client. So that is your browser basically, right? So browser is collecting the data, sending it to transport layer. Transport layer will send it to the network layer. Then it will be sent to the data link and the physical layer. So this last block over here is basically your data link layer or physical layer. And then the data is sent to the router. Routers will be forwarding the data to the end router. Finally, it reaches to the end router. Then the data is again collected by the physical layer on the destination side. Then it goes back up to the data link layer. Then it goes back up to the IP, and then TCP, and finally application. So the important thing that we should know is that, see, we have many applications that could be running on a computer, right? For example, if I use this machine, I could run a web server on it. I could run mail server on it, right? I could run FTP server on it. Many servers I can run on this computer. Now, when somebody sends a request for this particular computer, right? It is not only the computer that needs to be identified, but also the application needs to be identified, right? Because when the data comes in, I'm running multiple server applications on this machine. So which application that data belongs to, that is something also needs to be known, right? So whenever we do network programming, there are two informations which are important. One is IP address, right, or internet protocol address. So like each one of us has an address, right, our home address, for example. Now in that home, there could be multiple people living, right? So how do they know that this post needs to be going to which person? There's a name on top of that that letter, right? So there is a name of a person and then the address. So the address is basically your IP address that identifies your machine. Okay, so each and every single machine that we have connected on the network across the world, it has a unique IP address. So the IP address has to be unique, and IP address just identifies the computer, the machine that the data needs to go to. Okay. What identifies the application is the port number. So there is another addressing that is required, and that is a port number on which a particular server application is running. Okay. So combination of IP address and the port number will identify the computer and the application to which that data belongs to. Okay, so this slide is a little bit, but let me zoom it if I can. Uh, so on the left hand side, we have the header that is added by the IP layer. So when the data flows from the application layer to the TCP layer to the IP layer will add an additional information to the actual data which is there. Okay, what information it will add? This information. This is the header that is added by the IP layer. And I want you to focus on these two areas, right? Source address and the destination address. So if you look at the source address and the destination address, that is the IP address of the source machine who is sending the data, and the destination address is where the data needs to go to. Okay. So using these two addresses, the subsequent routers which are in between will be able to forward those data packets to the relevant routers. So it is possible that you have one router connected to maybe 10 other routers, but where that data needs to be forwarded depends on what is the final destination of the machine. Okay, so this is your IP layer header. If you look at the right hand side header, this is the TCP header, transport layer header. So once the application forms the data packet, it comes to the transport layer first. So the transport layer will be adding this as a header. Okay, and here I need you to focus on the first two elements. You see that it shows the source port number and the destination port number. Right, so basically this is telling me that which application has sent this data and to which application it is supposed to go to. Okay, so TCP will add this header and the IP will add the other header, which will then have the combination of IP address and the port number to identify which application on which machine this data belongs to or is coming from. Okay, so this is how the communication happens. So now, when you want to use the internet, right, in your application, how would you use it? So, in the operating system, it provides what we call socket interface. Okay, it provides something called a socket interface. And when I say socket or socket address, what should come to your mind is the IP address port number combination. So IP address port number combination is what we call socket or socket address. Okay, so every single application will have a socket address. Okay, and socket is something that we use in our code to do the communication between the two applications. Okay, so system calls are provided to us by the operating system to access the socket. First of all, to create the connection and then to communicate. So reading and writing the data from the socket, and then finally, once you're done with the network connection, then you can close it. And then after the TCP/IP, there's a hardware interface. So when we say hardware interface, what we are talking about? We are talking about, let's say, Ethernet. So there's a Ethernet card on my machine, right? So at the software level, I'm using socket interface from the operating system. Now the operating system has what we call device driver. So device driver is a code which is part of the kernel that is going to communicate with the hardware that is sitting on my laptop to actually send the data on the network cable. Okay, so that is what this is talking about, right? So here we are just concerned about this one, and this is the job of the operating system, how to deal with the actual hardware. Okay. Okay. So when we look at internet from the programmer's point of view, so all these slides which I gave you was just a basic introduction to networking, so that before you actually do the programming, you understand what the network is and what are the different components and so on, right? But now we need to look at internet from the programmer point of view, right? So there are three important aspects that you should know about. The first, obviously, is the IP address. Now, today, we actually have two types of IP addresses, IPv4, which is version 4, and IPv6, which is version 6. So what happened was that when the Internet Protocol was designed, right, they kept 32-bit value to represent all the devices in the world, right? But as the devices grew, the number of addresses then were less, right? And we couldn't accommodate all the computers that are available, all the devices. In fact, nowadays not only computers uses the IP address, even your phones have the IP address. Okay, each and every single network connection that you have in the world, whether it is a router, whether it is a phone, whether it is your laptop, any other device, even your Bluetooth devices, your smart watches, even nowadays your TV comes with an internet, right? If you go and buy a smart refrigerator, it also has an internet. So what is, you may have heard about the term IoT, Internet of Things. What is Internet of Things? Internet of Things is nothing but every single device is connected on the network, and you are basically using some controlling mechanism or some sensing mechanism to make sure that that device is operated efficiently, right, in optimum level. So one of the example is that, let's say for example, you have air condition in your room, which is a smart air condition connected as an IoT device. When a person enters the room, it detects that, okay, and there will be some controlling mechanism that will change the temperature, right? Depending on how much heat is generated within the room, it will control the thermostat internally, and it will adjust the temperature automatically. So that is what we call IoT devices, smart devices. So what I'm trying to say is that because of these many devices now connected on the internet, we don't have enough IP addresses, right? So what do? People came out with a new type of or new variation of IP address, which is called IPv6. IPv6 is 128-bit number, so you can accommodate obviously lot more devices than IPv4. Okay, although most of the network today, even the routers, most of them still supports IPv4 only. So there is a different mechanism to handle IPv6 address on the IPv4 network, which I'll not go into that much detail, but if you want to Google it up, you can look at something called as tunneling. Okay, so tunneling is the technique which allows the IPv6 addresses to be used with IPv4 networks. Okay, so if you are curious, just learn about that. So first of all, we need to map all the hosts. When I talk about host, I am talking about every single device that is connected on the network. Generally, earlier days, we used to call computers as a host, but now we have a lot more devices, right? Then we have second important aspect is what we call domain names. Okay, what is a domain name? So you access the website, right? You access DAIICT website, any website in the world. We don't access the website using the IP address directly, right? When you go to the browser, you are going to type www.google.com or daict.ac.in. You're not going to type the IP address because you may not be even aware what is the IP address assigned to that URL. Okay, and that mapping is what we call domain mapping. So domain name is basically the URL. Okay, so DAICT.ac.in is the domain, and the domain has IP address associated with it. So when you go to that particular website, a domain name or domain server. So first your request will not go directly to the DAICT web server. It will first go to another server which is called DNS server, domain name service server. So what the DNS server do? It will have the list of the domain names and the corresponding IP address, and it will return that IP address back to the client. Now the client knows what is the IP address of that domain that I want to go to. So now the request will be sent to the IP address, which is basically your web server sitting in the DIC. Okay, so that is how the route happens, and that is what this second part that you need to know about, right? Domain names and how do we get the IP address for the domain names. So there are multiple ways actually to get the IP address for the domain names. One option is the command ping. So when you do ping DICT, so you see this. That is the IP address of our DICT web server, which is available in a public domain. So anybody connects to the DICT server will be connecting to this particular IP. Okay. Similarly, I can do ping. So that is the IP address I am getting for google.com. So this data which I am getting back is not coming from the Google server. It's coming from the DNS server. So because DNS server is the only one who has the mapping of the domain names and the IP addresses. Okay. So that is something that you need to know about. And then the third one, which I've already shared with you, that a process or an application which is running on a computer needs to be identified by the IP address and the port number on both ends, client as well as the server side. Okay, so in the operating system, if we consider IPv4, and I'll talk about a bit about IPv6 also a little bit later, but IPv4, we have 32-bit addresses, and this is the structure which is declared in the kernel, and that is the structure which is storing the 32-bit address for IP. Okay. The only difficulty is that there are two ways to represent the IP address. See, basically what happens is that the IP address is internally converted into a hexadecimal format like this, right? The IP address normally that you look at is like this, which is what we call dotted decimal form. So dotted decimal form is where you have 3 dots and then 4 numbers separated by 3 dots. And each of the value is a single byte value, right? So when it is a single byte value, basically the maximum value can be 255, right? So 0 to 255 each value, and you have 4 of such values separated by dots. That is what we call decimal dotted notation. Okay, but internally we cannot actually store this number. So internally, to store the number, this data is converted into the byte format, and you have this 32-bit value, which is then stored in this structure. Okay, 2 ways to store the data: little endian, big endian. So little endian means least significant byte last. Big endian means most significant byte last. And that is depending on the operating system, these data is stored, right? So how the operating system is actually capturing the network address and then storing it internally, that is what determines whether it is big endian or little endian. Okay, so again, one of the job of the transport layer is to also make sure, or IP layer also to make sure that it has to identify that operating system is using which endian, big or little, and then it has to convert the IP address accordingly. Okay, so that's another job of the okay, we have a couple of functions, get ADDR info, which we'll talk about, and get name info. These functions converts the IP address into, so byte value into decimal dotted notation and reverse, right? Vice versa. So we'll look at the examples, but this is what. So domain names are hierarchical. Okay, so we have, when we talk about DAIICT domain name, right? We talk about DAIICT, sorry, .ac.in, right? This is how we write the address, right? So that in basically stands for India, right? So most of the countries or all of the countries have 2-digit acronym for the domain names. So if the website is located in UK, you will find it with UK. If it is in Korea, then it will be KR, whatever, right? India, IN. So except for many of the websites that you have in the US, most of the other countries you will find with the with these. So that is the topmost hierarchy. That is the topmost hierarchy. Yeah. Yeah. So .com and .org, you can also use it within the. So for example, if we want to use .com, generally we use co.in. If the website is posted in India, we use co.in. Com is generally available in the US. ORG is generally available in the US except for some government institutes. So you might find that some government institute may be able to use .org domain name. So again, there is a special. So when you buy your domain, you need to tell them that I want this domain. If it is available, they might give you. If you want to buy these special domains, there might be some extra fee involved. Okay, so you can buy. It's just that generally speaking, they would prefer to use this hierarchical domains. Okay. So as I said, for the educations, you could use edu also. For government, you would use go or something like that, right? Why in the US we don't have to write .us? Because I believe internet was created in the US. So originally, DoD, Department of Defense in the US, they actually invented it. They started using it internally for their defense use. But then it got popular and then started use it in the other part of the country as well as in the world. So that's why if you see many of the domains that you will find in the US doesn't have to actually write .us. In fact, I don't believe I've seen any site where we write .us at the end. Okay. That may be the reason. My thought. Okay. So NSLOOKUP is another command which also helps you to identify the domain names with the IP address. So that is something that we can use. Now, this slide is something where I want to mention two important aspects. So in the first area that you see here, right, we see that there are multiple domain names, like for example, csmit.edu and eecsmit.edu. So there are two domain names, but both are assigned to the same IP address. Okay, so it is possible in the DNS service that you can request for multiple domain names, but then have the same IP. So I don't know if you have noticed this. I have sometimes noticed this, that if you make a minor mistake in typing the URL, right? What happens? It still takes you to the same site which you meant to go. For example, I mean, I've not tried this, but let's say, for example, hdfcbank.com. Instead of hdfcbank.com, if you say hdfcban.com, right? If you somehow miss K, it would still take you to hdfcbank.com website. Okay, why does it do that? Because these famous people will buy all these domain names which are similar in nature, and they would map to the same IP address. Okay, so that even if you make a minor mistake, it would still take you to their website. Okay, so that is one important aspect. Second aspect is that, for example, website like Google, Facebook, Twitter, Insta, millions of people are going to that website on a daily basis, right? So having one IP address assigned to that one domain is not going to help, because millions of people has to be serviced only on one computer. How is that possible? Not really possible. So what can you do is you have multiple servers with a single domain name, each server having different IP address. Okay, and before those servers, how those servers are fulfilling the request, there is something called as load balancer before the servers. So before you hit the server, there will be something called as load balancer. It looks at how much load, how many connection requests that each server has, and depending on that, it will route the request properly where the server has a lower connection request. Okay, so again, what I'm trying to say is that website like Google will have multiple IP address assigned in the same domain name. Okay, so that is something that you should also know. So third part, internet connection. So I mentioned earlier that when we use internet connection, we use socket. So our socket address, which is the IP address port number combination. The connection is always going to be point to point, meaning that one application on one computer to the other application on that computer, but it is point to point, right? The connection is same point to point. Connection also has to be full duplex. When we say full duplex, what does it mean? When you say half duplex, meaning that even if your network connection, network cable allows you to send the data in both directions, half duplex means sending data only in one direction at a time. Okay, full duplex means sending the data in both directions at the same time. That is what the full duplex means. Okay, and then as we said, we need the reliable connection, which is provided by the transport layer. Okay. The third important thing that we should know about is the port. The port numbers are 16-bit integer values. So that means it goes from 0 to 64K. Usually there are certain port numbers designed to be used by specific service. Okay, and they are basically called well-known port numbers. So for example, if you have an email server, and if you don't change the default port, which is there in the email server, that port number will be 25. So anybody using email service will know that if I hit 25 port number on a given server where the email server is running, I need to hit port number 25. If you want to hit web server, it is the port number 80 by default. Okay, FTP server, port number 21 by default. Right? Now, one thing I would ask you is that see, when we connect to the VPN on the DAIICT website, if you recall, we type the IP address 10.155.56, and then we put colon, and then we put the port number 8090. Have you tried that? Do you use that? Yes? Okay. So what is that? So there's a web server running on that IP address, of course. Okay. But that web server is not using the default port of 80. Because it is not using the default port of 80, we have to explicitly mention what is the port number on which that web server is running. That is why we have to provide colon 8090. So colon 8090 is the port number on which that service is running. Okay, so whenever we are using the default port numbers for a particular service, you don't have to specify the port number. But when the web server or email server or FTP server is configured on a different port, not the default, then you do have to specify the port number. Okay. How do I know what are the default port numbers? This is the file that provides that information. So if you go to any Unix implementation, and if you open that file, you see that on the left hand side, you see all the service names. Okay, and in the center, you see the port numbers. On the right hand side, you see some of the descriptions. Okay, so this is the file that will tell you what service is running on what port number. Okay. Now, when we talk about port number, I mentioned there are two types, ephemeral port and the well-known port. So well-known port is on the server side because the server is running a particular application and accepting the connection request on a particular port number. But let's say when you connect to a Google server and the Google server needs to reply back to my client, a browser running on my machine also needs to have a port number, right? Because my machine does have an IP address. That browser connection requires a port number so that the Google server can send the data back to me, right? So those kind of ports is what we call ephemeral ports. So ephemeral ports are the ports assigned to the client by operating system automatically. We don't create that port number. We don't assign that port number in our code, but it is assigned by the operating system. Okay. So that is what the example that is showing you here. So in the socket pair is where the connection is going to be established. So you have the client IP address, the client port number, server IP, and the server port number. And on the client side, let's say this is the IP, this is the ephemeral port that is assigned by the operating system, and then this is the server IP and the well-known port. Okay, so that is what that is how we establish the connection between the two applications. Now, as I mentioned earlier, because we have different port numbers, we are able to identify different application on the same server, right? So let's say in this example, we have the web server, which is running on port 80, and the echo server, which is running on port 7. So that is how we are able to identify two different services or two different applications. Socket interface has been used since 80s. It was first developed in the BSD distribution, virtual distribution for Unix variant in 80s, and currently it is supported in many operating systems. Okay, now, see, we said we want to use socket and socket address, but all the devices that we use on Unix-based operating system are treated as files. Okay, and so the file descriptor is something that needs to be assigned to every single device. Okay, for example, we use regular file IO, right? Regular file IO. How do we access the files? We open the file. When we open the file, what do we get in return? File descriptor. So all the reading writing that we do is done using file descriptor. Then we use pipes, another device, another type of communication. How do we open pipe? Using pipe system call. But what does it return? File descriptor. So all the reading and writing that we do in pipe is using file descriptor, right? Same thing for the network, for the socket. Okay. So we do have the socket address, IP and the port number, but the communication has to happen using file descriptor in the Unix-based operating system. And therefore, there will be a mapping done between the client side file descriptor to the socket address, which one I'll tell you later. And then the file descriptor on the server will also have the connection to the socket address, right? The mapping to the socket address. And that is how the communication is going to happen. So all the communications still happen using file descriptor. Any questions so far? Clear, understanding everything, or yes? How does?
So how do?
Good. Right. So how does the server know what is the ephemeral port number? Right. That's the question. So the question is, when the client is going to send the data to the server, the client application is going to send the data to TCP layer first. The TCP layer is going to add the header. That header will have the source and the destination port number. That is why you have to add the header. Right. So basically, the application will be forming a simple packet, simple data, and then there will be a header for right. So this is the information that tells you what is the ephemeral port, right? Any other question? Okay. So socket address is something that we need to store, as I mentioned. Now we have two different variants of the socket address. So again, originally when the socket address structure was defined, it had this padding that you see at the end. So this is the structure which is storing the IP address, and this is the structure which is storing the socket address. Well, how do I know that? Well, if you see, this is the IP address, right? And then this is the port number. And this is the family. So family is usually used as AFINET for IPv4, AFINET 6 for IPv6. Okay. Original plan was to use the same structure for both versions, but when researchers designed IPv6, they actually created sort of like a new protocol kind of thing, not just expansion of the IP address, but they also added few more features into it. Because of that, they needed more variables more members in the structure. So they happened to create a new structure completely, which is on the right hand side. So you see that there is a new attribute called flow info. There's an attribute called scope ID, right? So these two attributes are new in IPv6, which is not there in the IPv4 structure. Okay. Apart from that, all the information is the same between the two structures. So IP address stored for each of these IPv4 and IPv6 in this structure, and then the socket address are here. Now, I mentioned that we need to know the IP address for the domain name, or the you have the URL and you would need to know the IP address for the specific domain name. So what we do is that we use this particular structure, and there is a function called get host by name. Okay. So get host by name system call is where you will provide the URL, okay, URL of the domain, and that will return you this particular structure. Okay. And if you see the last entry over here, it is a list. And that list is nothing but list of IP addresses. Okay. So this is your host name. It will tell you also what is the address type that it is getting, the length of the address and the actual address. And then if you just get the 0th index address, then it is going to be your first IP, which is also constant defined, by the way. Okay. So this information is available in these header files. So these are the header files you will have to include in order to access the function as well as the structure. So this is going to be doing something similar to what the NS lookup will do. It will provide you all the IP address, but in your code. NS lookup is the terminal window command, right? You don't get that information inside your code. So this is the code which will provide the information inside your code. Okay. This is one more function that we should know about. This is the function that is going to convert the byte value of network address into the decimal dotted notation. Okay. If you see, it says N to A at the end. So we have seen, or you may have used I to A, integer to ASCII. Then you may have used F to A, float to ASCII, network to ASCII. Okay. So network address to the decimal dotted notation. So this is the code, right? And we are basically saying that we are passing one parameter, which is the URL or the host name. That parameter is going to be passed to the get host by name, which is going to return me age. Age is nothing but the pointer to this host entry structure. And then once I have the value of age, I will iterate through the header list or the address list, sorry, and I'll print each of the IP address which I'm getting back, right? And how do I print? I will print using inet N2A. If I don't do it, it will display the data in the hex format, right? So you will have to use, in the printf, you will have to use %x instead of %s. Right, %x is to display the data in the hexadecimal format. Okay, so that is the difference that will come here. So let us execute this code. So I'm printing only one IP address, I believe, right now in the code. No, currently it is returning me only one IP address. So this is how you would be able to get the IP address from the domain. Okay. Now the function that we use, get host by name, has two variants. The variant that we used are generally providing you information about the IPv4 addresses. If you want to get IPv4 as well as IPv6 addresses, there's a second variant here, and that is called uh, get host by name 2. That's all. Okay. So you just replace get host by name 2. You will get the IPv6 addresses also. Okay. So this get ADDR info function is a bit more complex than the get host by name. Uh, what is special about it, right? So get host by name also gives us the IP address of the domain name that we have, right? But then we use the get ADDR info. Okay. So briefly, I'll explain what is the difference theoretically first. See, in the transport layer, if you recall here, we said that there are two types of protocols. There's a UDP protocol and there's a TCP protocol. Both come under transport layer. Okay. In some cases, you don't care about reliable connection. In that case, you could, so that is just a single packet that you're just transmitting. Or maybe you just want to broadcast something. Okay, and you don't care whether the data reaches or not. In that case, you can use UDP. So UDP is unreliable connection, but it is most likely used for like broadcasting some general message to everyone, and you don't care whether it reaches or not. Okay. Uh, then there are other types of protocol like IPv4, IPv6. Then you may have the Ethernet usage or your wireless usage. Each one of them also uses different protocol. So the difference is that certain IP address, for example, if on my laptop, if I have an Ethernet card and I also have Wi-Fi, I also have Bluetooth. Each one of them has an IP address, right? A separate IP address. I want to do the communication only using a specific type of network. So I only want to communicate using Ethernet and using only IPv4 address. So let's say Google provides me both the addresses IPv4 and IPv6, but I don't want to use IPv6. I only want to use IPv4. Okay. So this get ADDR info allows me to do the filtering. Okay. It allows me to do the filtering. It basically, I can provide the hint, I can provide the filter to this function, and I can say that I want this socket address only if it matches this criteria. Okay. That is what the get ADDR info function does in a nutshell. So you see this third parameter here, right? It's called hints, and that hints has basically it is the type of ADDR info structure, and ADDR info structure is something like this. Okay, so you can provide the type of IP you want to use. You can provide the socket type. So when I say socket type, when we say sock stream is used for TCP. Sock dgram or a datagram is used for UDP. So in case if you want to use only UDP type of connection, then you call for sock dgram. If you want to only use it for IPv6, then you say AF INET 6. So this information you can provide here, right? And what operating system will do, it will search for that type of connection on your machine and will only return the socket address that is matching that criteria. That is the only difference. Okay. Question? Yeah. What is the advantage of? Advantage of UDP over TCP is only that you don't have to establish the connection, which means that the data will flow a little bit faster. And you can use it for broadcast medium, because when you do TCP, if you try to set up connection with each and every single other server, it will take a lot of time. And if you really want connection to all of them, right, and if one you are not able to establish, then what do you do? So the point is, as the name says, datagram packet is where you for example, uh, see, on our systems, everyone might know that it is syncing the time with the common server. I don't know if you know that. Do you? Yes? No? No? So it does do that, right? So when you say that automatically adjust the time or sync the time, it is going to sync the time to the server which is there in the GMT time zone, right? And it is going to sync the time. So when that particular server is going to be broadcasting that message across the network, okay, and whichever computer receives that will be adjusting. But then you don't have to worry about it. Why? Because again, after 5 minutes, 10 minutes, again that broadcast will come, and maybe you missed it first time, you may sync it next time, right? So the idea behind, so the use of the UDP and TCP is different, right? TCP is meant for reliable connection, where you want to ensure that the data must reach to that particular point, right, and intact. UDP is meant for generally a broadcast medium where you don't have much, adherence to the timeline, or even to ensure that, okay, if you miss the packet, you miss the packet. Doesn't matter. Okay, so different usage. Okay, so I would not call it as advantage over one versus the other. Basically, it is like using two different methods for two different applications. That is what it is. Okay. So as I said, one more advantage of the get ADDR info is it is thread safe. Okay. Get host by name is not thread safe. What does it mean? It means that if you have a threaded application and you want to use you want to get the IP address from the domain name, it is better to use the get ADDR info in that application, because if you are running that code inside the thread, there is a locking mechanism implemented in the get ADDR info. In the get host by name, there may not be, right? So you could have race condition when you use get host by name compared to ADDR info. Okay, so that's another advantage that we can use. So again, as the disadvantage says, it is more complex than many applications may need it, but if you want to use it, you can use that. Get name info is the opposite of get host by name. So if you have the IP address and if you want to get the information about the service or the name, then you do the reverse. So there's an example given here. Okay, so in this example, instead of using the get host by name, we are using the get ADDR info, and primarily, if you see this one, does everyone know what memset does? It what? Sorry. All the elements. Yeah. So basically we are assigning 0 value to the whole structure, right? Basically we are nullifying the structure. That's what we are doing. And if you see the hints, right, hints is nothing but a type of ADDR info structure, right? So in the hints we are going to first set what we actually want, right, as a filter, and that is what is done over here. So what we are doing is we have a constant that says that if the user is requesting only IPv4 or IPv6, you can also use a command line argument if you want to. I've just used a constant just to show you an example. Okay. So if this constant is defined, then we are going to request for IPv4 addresses only. And as you can see, we are requesting only for TCP connection. Okay. So we will request for TCP connection. We will request only for IPv4 addresses. And then we call get ADDR info using the hint. Okay. When we do that, get ADDR info is going to return me a linked list. Okay. It is going to return me a linked list with the list of IP addresses matching the criteria. That's all. Okay. So this is the linked list. This canonical name or canon name is basically the host name, and then AI ADDR is the IP address. Next is the pointer to the next node. That's all. Okay. So that is all the information I am going to get. When you have null at the end, that is all your IP addresses that you have. So once we have this list P, sorry. Once you have this list P pointers to that structure, ADDR info, this is my output, right? This is my filter input, this is my output. So once I have that, I'm going to iterate through the list using the AI next, which is the pointer variable pointing to the next node. So I'll iterate through that list, and then I'm just going to print the values, right? The service, the host, and so on. Now, one additional thing that we can use in the get name info, which is the function that provides us the name instead of the IP address, is the flags. So in the flags, what we are saying is whether you want to see the numeric value of IP address and the service name, or the, so port number 80 will be displayed if you say you want the numeric value. If you want the service, it will display HTTP. So HTTP is the name of the service. The equivalent port number is 80. So whether you want HTTP to be displayed or you want the port 80 to be displayed, that's all. Right? So that is what this flag is doing. So I'm saying that I want the numeric host value, which is the IP address, in the numeric value, and also the service in the numeric value. So these are again the constants which are defined in one of these header files, which is what we are using. So right now I'm requesting for the numeric value, right? So that's why it is displaying this, right? If I were to change that, right? So it's displaying this information. Let me go and change the. So what I'll do is I'll comment this line out. So now you see, instead of the IP address, you are actually seeing the name of the host and the service name, right? So basically that two IP addresses which we saw here, this IP address is mapped to this particular server. This is the web server, okay, most likely located in Bombay, right? So this is the name of the server which is mapping this particular IP address, right? And this IPv6 address, so this is, by the way, the IPv6 address for the Google, right? So this IPv6 address is mapped to this another server. And the service, instead of saying 8080, it is saying HTTP for the web service, right? So you can either display this information in the numeric format or the textual data. Okay. I think I'm going to start the client-server communication using socket interface, and I think it will take a little bit of time for me to go through each of the step, and I don't want to break in between. So I'll stop here for the lecture part. If you have any questions, I can take them, or we'll talk in the next class. Yes.
We have some different protocols.
Okay. When you say different protocol, what do you mean? You mean what? HTTP to MQD. So those kind of protocols are meant for connecting to the specific application. Okay. So you can't have HTTP connecting to MQD. You can't have FTP connecting to HTTP. But you can have Ethernet protocol, IP protocol, connecting to the 4G, which is 802.11. Okay, that is possible because the router understands those different protocols. Why this is not possible? Because see, when you say HTTP, what you are saying is you want to connect to the web service. Okay. Now, when you want to connect to the web service, on your client side also you need to initiate the web service request, and that request can only go using HTTP. If you want to connect to the FTP service, you have to start using the FTP as a protocol. You can't use HTTP and then connect to FTP. You can't do that, because see, HTTP means port 80. Port 80 is where always the web server is going to run. So if I use FTP, the port number will change, and that port number is not where your web server is going to run. Are you getting what I'm saying? So that's why that protocol change can happen only below the application layer, not at the application layer, because that means you are connecting to a different application, not the same application. Okay? Yeah. Yeah.
So how first time speaker reaches to TCP, because it doesn't have any IP address. How it will reach TCP?
How it will reach to TCP? So you are talking about domain name, or you are talking about? Yes. 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 No, it will be provided by domain server. So what basically will happen? See, first, so there will be two trips that will have to happen. So in the first trip, the application will tell what is the URL for which it wants the IP address. So that information is directly sent to the domain server. Okay, domain server IP address is global. Everyone will, if you Google it up, it will know what is the IP address of domain server. All the 13, 14 DNS servers are there. Okay, so at that time the IP address for the computer will be known, right? We know that, right? But the IP address of the Google server we don't, right? So we can't send the packet directly to the Google server. So what this machine will do, first it will create the packet, and the transport layer, the destination IP will not be the Google server IP, but it will be the DNS server IP. Okay, so first the first the data will be sent to the DNS server because the destination IP is the DNS server. Now the DNS server gets the request and it replies, right, in the data packet saying that, so this guy will say that I want the IP address for www.google.com, right? It is in the data packet, right? The IP address, source IP is this computer's IP, destination IP is the DNS server IP. Now the data goes, the DNS server replies. In the reply, it will say that the domain name google.com has this IP address. So now this computer knows what is the IP address of google.com. So next time when it forms the actual data packet for google.com, there the destination IP will be for google.com. Getting the point? So it's basically like this. So this is your client. This is your DNS server. And this is my Google server. Right? So basically what is going to happen is that first time, this guy doesn't know the IP of this one. So it sends the request here. Right? In this request, the destination IP will be for DNS server, which is known to everyone. Okay. Now this guy responds with the IP of the Google server. Now this guy knows what is the IP of the Google server, and so now the connection request goes over here. This is how it is done.
How clients know that what is the address of the
That's what I said. It's global. It's globally available. DNS servers IPs are globally available because every single domain is hosted on the on the DNS server. So DNS server IP is always available everywhere. And as I said, there are like 13, 14 DNS servers across the world, and the IP address are globally available. You can Google it up. You will find it. Any other question? Okay. If no questions, we'll stop here and we'll continue on Monday.